right, welcome back from the field. Dust off the cobwebs of being outside, pick the ticks off your body. Now it's time to enter some data. And you guys have this sheet here. So you hopefully, while that you were watching all that and seeing everything that was going on, you filled in some of this data. So looking at plot 1, plot 2, plot 3, plot 4. And yeah, you want to see what I got? Let's compare. All right, let's click over. So from plot 1, I had a spruce evergreen forest. Some of the observations I made was ground covered with cones. It was all spruce, and it was near an open field. Now, feel free to add any of that into yours if you missed something. There was one spruce tree at 22-inch DBH, standing for diameter breast height. I got my pH readings here. I did a little math, so I averaged them. There's the dogs barking. And I added all 5 of these numbers together, and I divided by 5, and then I rounded it to the 10th place, okay? And so I got 7.1. Going on to my next plot, I had, you can pause and do whatever you need to do here, red pine evergreen forest, observation, lots of pine needles on the ground, almost no vegetation, some deciduous trees nearby. I had a red pine, 15-inch diameter breast height. I got my pH readings, I did the math, I got the average, and that is here. So on. I don't think I need to say everything here. You can look at this rocky, uneven ground, hard soil. Got my average there. And then on my last one, I had 2 trees. I had 2 red maples, a 10-inch and 7-inch DBH, a sugar maple at 9-inch DBH, and I have an average there. So data collection. This is this section of the lab where you're going to put your raw data in. I'm not making any observations about the data in this step. I'm just putting my data in. Sometimes this can just be a list of facts or charts or observations. It can also have pictures, and all sorts of things can go into your data collection zone. All right. Now the good part, well, you could call it the good part. This will be a hard part for a lot of people, is now I have some good data. I want to analyze it. And the best thing out in the world to analyze data is graphs. Look at the graph I created here. I'm going to show you how I made this. So I used Google Sheets to make this, by the way. And I have a bar chart showing the pH on my y-axis, and my x-axis is showing 2 types of evergreen forests and 2 deciduous forests with the specific types of tree species that made up evergreen: spruce, red pine, oak, and maple. Looking at this chart, you can see the pHs are nearly the same. This is a little bit of change, but this data is showing basically a consistent pH that goes through it, okay? I did also, I want to mention this now, and then we'll show you how to make the graph. I put a line or 2 in that analyzes the data, that tells what this graph says. So here I say, the graph shows, let's see if we can get, clicking. This graph shows that the pH for all 4 plots is nearly the same. It is noted that the red pine forest had the lowest pH at 6.8, while the other 3 plots were all at 7 or 7.1 pH. Really almost no change there. So let me show you how I made this graph. I went and I opened a Google Sheet, okay? And I can take, this is the chart that I made, but let's drag this to the side. And I entered some data into our columns and rows here in the data sheet. Now, how you enter data in a Google Sheet is going to really affect how your graph comes out. So keep that in mind, and we'll play with this more as the year goes on. But for right now, I basically had 3 columns. Was it evergreen or deciduous? What was the plot tree type? And then what was the average pH? So I took only those average numbers. So I have 3 columns here, and that's the data I need. To get this into a graph, I can highlight my section, okay? And then you want to have it make a graph. A couple ways to do this. You can click this little graph insert chart button here. If you don't see that, you can come over to insert, and chart is there as well. So I'll go ahead and click insert chart. I think this is going to lay one right over the top. All right, so it automatically, for me, picked a column chart. Now, Google Sheets is going to want to be smarter than you. And sometimes it might say, oh, I think a line chart is going to be the best. But looking at that, I don't love that data. For this data set, I really like that bar chart that goes with it. So I'll kind of click and look through here again, go back to that column chart, and here it is popping back up. It auto-populated all of this good stuff in here. It was missing a couple things, though, that I really like in my charts, and that's some labels that go along with things. So if I click over on Customize, I can do chart style, chart axis, and titles. This is the one you want to click. So I could first click on that, and now I get to pick what I want to change. So chart title was the first thing that I changed. And in here, I put in what you can see in the other graph. I think if I can still shift this, soil pH for evergreen and deciduous plots, okay? So I just typed that in there. So soil pH, just to show how that worked. Look, it just popped right up there. I also labeled, if you look at this other one, the y-axis. Okay, the bottom, the x-axis is pretty well labeled for me. So I would go onto here and call this the vertical axis or the y-axis. And then I called this soil pH, just showing what those numbers are showing. Boom. And it pops up right there. Okay, so really nice. Now I have a graph. Basically, this is done. I'm going to click over to my one that I like a little better, and I can close this toolbar on fixing things if I want. This was the one I liked the best. So this is my graph. I want to get this in to my lab. It's pretty easy to do. So all you need to do is Command C. So I copied it, right? And I bring that over in my lab and I Command V and it pastes it right in. It actually makes it a link. So if I ever go back and change something in my sheet, it will automatically update that in my lab graph because all of these Google documents talk to each other. So boom, boom, boom. I now have some analyzed data in my lab. Looking good, everybody, okay? If you need to pause it here for a sec to get caught up, do that. All right, coming back from our pause, let's move on to errors. Any lab has mistakes. You own them, and it kind of makes it realize that you actually know what you're talking about as a scientist, that you're aware of what might have been wrong with this. And this also helps you kind of repeat the lab. To really validate this answer, I would need to do this lab again, or maybe have someone else do it, look at my data, try to copy it with modifications based on my errors. So errors I came up with, the soil pH may have been affected by the rock types of the area. So soil, what I'm learning is maybe that soil pH isn't about the trees, it's really about the rock types. And I could test granite rock types compared to schist rock types and see if that really makes a difference. The pH probe could have been more precise. So did I have the most scientific tool that could really answer this question? No, I did not. And I'm going to own that. Each plot did not have the same number of trees or the same age and diameter. Is it possible that the number of trees in my plot affected this? It is. It is possible. So keeping that in mind, that there was some inconsistencies in my plots. They did not all have one perfect tree in the middle. And in the maple plot, there were white pines nearby that could have affected the soil pH. So there was some evergreens near my deciduous forest. I'm mentioning that. Okay? Awesome. So one note I'm going to make here, and maybe I'll say it again at the end. Look at my lab compared to yours, and you'll notice if I looked at data analysis and errors, come on back to mine, I've removed the directions. When you're finished and you don't need the directions anymore, take them out of your lab. Okay, that is an important part. You will lose points if you leave them there. So in my final version, I left this one here to help kind of remind me that I need to remove directions when I'm done. I'm also kind of a stickler for font size and style. So I want consistency in all, I don't care what font, don't go crazy, but a normal font, but it's the same. It's the same size, it's the same font everywhere you go. If you don't know a trick for that, you can highlight a section of font that you like, use this little kind of paintbrush roller tool, and then come over to any other one, and it will make it automatically that font. Oh, look at that. That's beautiful. It makes it consistent. I'm going to undo that because I liked the way that one was before. Cool. So get rid of those directions. You'll notice, are there any underlined red or blue things in my lab? Oh, there's one, but that's because they were confused about diameter breast height. They really didn't know what I was talking about. So yes, my spelling seems to be pretty on. This isn't the heart of it, but you will lose points if you have misspelling in your lab. All right. Conclusion. This is the mama. This is the biggest one of it all. If you go to conclusion right here, is a link that will show you exactly how to do the conclusion. It's such a big one that the directions require their own link. If I go to mine here and I click that link, what on feature I like now, it pops up right here over the top of my page. And I actually made this link so it fits nicely there and it's all nice and big and clear. If you follow each one of these steps in your conclusion, you will have a perfect conclusion, or at least by my rubric and my standards, okay? So let's look at mine here and see how I did. Explain the question the experiment was trying to answer and the purpose of the experiment, okay? I can close it. This lab tested if evergreen forests have a different soil pH than deciduous forests. And the purpose was to understand if different forests in the same area have different soil pH levels based on what type of tree species are in them. Boom. Let's go back. How did I do on that? Did I explain what the question the experiment was trying to answer and the purpose? You bet I did. I kind of went right off that. Next thing I'm going to do is talk about how I got some data, okay? Data was collected by creating 4 different plots in forests with different dominant species. Tree species and diameter were noted for each plot. That's how I collected data, okay? So I took not necessarily word for word what was in my methods, but it's an abbreviated version of it. A trick here is a lot of times you can go back to what you already have. Okay, so the next one is key. I'll show you how to do that on that one. So, I jumped. So how data was collected. Note additional data that was collected or how different variables were noted. Okay, so I actually skipped. I got mine a little bit out of order, but that's okay. Well, I think I got that. Tree species and diameter were noted for each plot. So I noted everything. I'm on to my next step. Sorry, I'm getting off track. It's late night. State the hypothesis. Okay, so for this one, pretty simple. I said the hypothesis stated, and you know what I did actually? Zoom right up here. I already have a perfect hypothesis. I took it and I copied it because it's already perfect. So I brought it here, Command C, come back down to my conclusion, and the hypothesis stated, and then I put Command V. Now I corrected it. I got rid of that capital and I cleaned it up. So that is the same hypothesis from before that finishes here. Next step is to say if it was correct or not. I'd like you to phrase it this way. The hypothesis was incorrect. Hey, so wait, are you telling me that I was wrong? Do I lose points for this because my hypothesis was incorrect? No way, Jose. Like this is, you don't lose points. You know what? Scientists are wrong all the time. There's actually more incorrect hypotheses, is that the word, hypotheses, than correct ones. And you actually learn more from your failures than your successes. So don't feel bad if your hypothesis is ever wrong. But it wasn't wrong. I was wrong before. All 4 plots had the same pH. I'm squeezing that together, and I give a little to back it up. Exception was the red pine forest had a slightly lower pH of 6.8, and the other 3 plots were 7.0 and 7.1. I give a little, okay, so here I state the hypothesis. Was it correct? What did the data show? Be specific. Use numbers. Did I do that? Yeah, I did. I did do that right here. This is a very small change in pH. So I just kind of back that up that, yeah, there was a change, but it was very small. I like this line. This is kind of one of my favorite lines. What other observations were made? Sometimes the golden nuggets here are in this line. So you're looking for something, but you observe something else very interesting. It was observed that each plot had different undergrowth and different plant growth on the ground. So that was not related, but observed that, that pine forest had no undergrowth, but the deciduous one did. Interesting. Final line, we're getting to the end. In conclusion, and then you say what the experiment showed. So you're finishing it off. And I'd like you to always start with that line to really highlight it. In conclusion, the data showed that evergreen and deciduous forests in the Thetford Hills State Forest have very similar soil pH, and that soil pH of around 7.0 can support an evergreen and deciduous forest. I learned something. Maybe it wasn't even what I was looking for. That evergreens and deciduous can live in a nice, stable pH balanced soil. Boom. I'm going to kind of scroll right to the middle and pause if you won't need to type this in. This is a big one. All right, welcome back from the pause. We are almost there. We have one last step, and this is what makes the scientific method a cycle. This step brings us back to the beginning where the experiment all begins again. True scientists never end. It's just coming back to the start. Future study. From what I've learned here, what do I want to do now? You are free to copy mine for this one, and I encourage you, did you think of something else you might want to test through all of this? Could you frame a question with some variables that go with that? This is what I came up with. Does soil temperature affect the tree species in a forest? Oh, interesting. It doesn't seem to be the pH, but maybe these forests all had different soil temperature. Does rock type of an area affect the soil pH? So I could go to some different places with different bedrock. Should I fix that? What's wrong? Type. Oh, it needs an E. And see if that changes anything in my experiments. And that would lead me back to a pretty cool study. Should we do that next? Do you want to do the temperature one? Go back to the same plots and take some temperatures? Maybe that would be interesting. That would be a next step of our lab cycle. All right, guys, this is a big assignment. Really good luck. I'm going to slowly scroll through this document one more time if that's helpful for anybody and they want to pause it at any point. So let me go up to the top and you can see it all as I scroll through it slowly. I'll just talk while I'm doing that. But the expectation here is you're going to fill this in just like I have. I know it's a little tedious to have you copy and write all this stuff, but there's learning that happens in that copying and writing as well. And you should be able to get a perfect lab because you have a great example right in front of you of a lab that really shows proficiency in all of the standards that we're covering this year. Oh yeah, one step, I got to get rid of my directions. Oh, don't forget that. There you go. Get rid of those. Keep all your fonts the same. Here's that conclusion coming up. And future study. Great. Good luck, everybody.